Okay, energy density. We're going to be examining this lesson. There's a lot of math formulas, so I'm going to help you all through it. All right, so the human body cannot operate without energy. Food is the energy supply for our body. A combustion engine cannot work without fuel. This is the energy supply for the engine. An electric motor cannot work without electricity. A battery is needed for this. If the body or machine is without energy, it cannot work. Energy density is the relationship between the amount of energy and the weight of that energy. Energy can be measured in a number of units. In food, joules or calories are used. In batteries, the charge milliamps per hour or amps per hour, and the voltage provide the amount of energy. To convert between these, you need to know that 1 watt hour equals 3,600 joules equals 3.6 kilojoules. All right, so what is the energy source for the combustion engine? It's fuel. Energy source for the electric motor, electricity. Energy source for the human body, food. What happens if the human body or machine has no energy source? It cannot work. What is energy density? The amount of energy per weight. You eat food to provide energy for your body. Look at the wrapper. How much energy is 100 grams of this cookie? Well, if you look over here, energy is asking for kilojoules, so it's 1,500. How many milliamps can this battery supply for 1 hour? Well, if you look over here, it says 2,000 on the side of the battery. What is the voltage of the battery? It says right here, 1.2. Okay, so here's a chart we're going to have to start to fill out. To compare the battery's energy density to the cookies, we need to know how much energy is in the battery. How many amp hours is 2,000 milliamp hours? Now we're going to have to use our calculator. Clear 2,000 divided by 1,000. We come up with 2. And that's because what we're doing is milliamps per hour to amps per hour. So that's why we need to divide by 1,000. 10. To calculate the energy in the battery, you need to multiply the voltage by the current. Multiply the voltage by the current that the battery can provide in 1 amp hour. So we're going to be doing 1.2 volts times 2 amp hours. 1.2 times, that's 1.2 volts times 2. It's 2.4 watt hours. 11. So 1 watt hour is equal to 3,600 joules. How many kilojoules is 2.4 watt hours? So we're going to use our calculator again, and probably the simplest way to get you there is 2 8.4 watt-hours times 3,600 joules is 8,640. And then we're going to divide that by 1,000. To get to 8.64 kilojoules. All right, on the cookie wrapper now, the amount of energy is given per 100 grams. How many kilograms is 100 grams? Well, here the equation for this one would be 100 divided by 1,000, because we're going to kilograms. Remember, kilo is 1,000. So 100 divided by 1,000, so 0.1 kilogram. So 100 grams is 0.1 kilograms. All right, question 13. The battery's weight is 40 grams. So how many kilograms is that? Well, we're going to take that same idea we just learned, and we're going to divide 40 by 1,000. And here we see it's 0.04 kilograms. Question 14. The energy density can be calculated by dividing the amount of energy by the weight. Calculate the cookie's energy density. So here we need to do another division problem. 1,500 kilojoules divided by 0.1 kilograms. And here you type in 1,500 kilograms. 15. Calculate the cookie's energy density in millijoule kilograms. So here what we need to do is another division problem. We're going to be dividing 15,000 kilojoule kilograms divided by 1,000, and we're going to get 15 megajoule kilograms. Calculate the battery's energy density. All right. So we're looking at 8.64 kilojoules divided by 0.04 kilograms. So 8.64 kilojoules divided by 0.04 kilograms is 216 kilograms. So we see the cookie's energy density is much higher than the battery's energy density. And you can compare those two numbers there. So question 17, calculate the battery's energy density in megajoule kilograms. So to be able to get there again, we need to divide 216 kilojoule kilograms, divide that by 1,000, We have 0.216 megajoule kilograms. Okay, and as it says, the average energy density of an HV battery. All right, so question 18, what has the greatest useful energy density? Well, in this case, it's going to be the cookie. And 19, the cookie has an energy density of 15 megajoules per kilogram if the energy is converted by the human body. A battery has an energy density of 0.216 megajoules per kilogram if converted into electricity. How many times more energy can the human body extract from 1 kilogram of cookies? So here we need to go back to our calculator again. We're going to do 15 divided by 0.216 equals, so about 69 times. All right, so 69 times more energy the body can get out of the cookie